Good morning and welcome to Chapter 9, Section 2, Arithmetic Sequences and Partial Sums. You will need to pause the video at this time and copy down the information. Now we're going to find out how to find the common difference. You find the common difference by taking the second term, which in this case is 8, and subtract the first term, 5. And we get 3. And we try this for a couple of them just to make sure we're getting the right common difference. So we take the third term and subtract the second term. That's again 3. And one more time just to make sure, 14 minus 11 equals 3. So yes, 3 is our common difference. Okay, let's look at the next one. I've got 5 minus 9, which is negative 4. I've got 1 minus 5, which is negative 4. And I've got negative 3 minus 1, which is also negative 4. So that means my common difference for this set of data is negative 4. Okay, let's look at something that's just a little bit more difficult because it's got fractions in it. Okay, so we have 7/6 minus 1. Well, I need it in same denominator, so I'm going to rewrite 1 as 6 over 6, which is equal to 1/6. Okay. Next one, 4/3 and 7/6. So my common denominator is going to be 6. So that's 8 over 6. That's 4/3 minus the 7/6. And that gives me 1/6 again. Okay, I've got 4/3 and 3/2. 6 is still going to be the common denominator. So this is going to be 9/6 minus 8/6, which is equal to 1/6. And again, we can see that my common difference is going to be 1/6. You'll need to pause the video again to write the nth term of an arithmetic sequence. There is a linear form and an alternative form. We'll be using it in the next slide. Okay, the first example, find a formula for the nth term of the arithmetic sequence whose common difference is 5 and whose first term is negative 1. So we want to find a sub n equals. So a sub n equals, and our first term is negative 1 plus, and that's n minus 1 times my common difference, which is 5. Okay, that gives me a sub n equals negative 1 plus 5n minus 5. All I did was distribute the 5. Well, now all I need to do is clean everything up, collect like terms, and I get my arithmetic sequence to come out to be a sub n equals 5n minus 6. Okay? Now, the 8th term of an arithmetic sequence is 25, and the 12th term is 41. Write the first 5 terms of this sequence. Well, first off, again, we know the 8th term, so that's a sub 8 equals 25. And a sub 12 equals 41. Well, the difference between the two terms is 4 terms. Well, that means I need to find the common difference. So to do that, I would take the 12th term minus the 8th term and divide it by 4. That gives me 16 over 4, which equals 4. Now I know that my common difference is 4. Now I can take either one of them and set up to find my sequence. I'm going to use the 8th term. That's 25 is equal to a sub 1. This time I'm looking for the first term. Excuse me. So, and I know that 25 was the 8th term minus 1, and my common difference that I found was 4. So this is 25 equals a sub 1 plus, and that's going to be 7 times 4, which is 28. Okay, all I have to do is subtract the 28 from both sides, and I get a sub 1 equals negative 3. Then I can find my first 5 terms by using my common difference. So that's negative 3, 1, 5, 9, and 13, my first 5 terms. Okay, one last example. I want to find the 10th term of an arithmetic sequence that begins with 8 and 20. That means term 1 and term 2 are 8 and 20, respectively. So a sub 1 equals 8, and a sub 2 equals 20. When I subtract the two, 20 minus 8, that tells me that my common difference is going to be 12. Okay, then all I want to do is find the 10th term, so I plug into my formula. A sub 10 equals 8, the first term, plus 10 minus 1, my n minus 1, times my common difference of 12. So that's a sub 10 equals 8 plus 10 minus 1 is 9. 9 times 12 is 108. So a sub 10 is equal to 116. Okay, the next thing we're going to do is the sum of a finite arithmetic sequence. You will need to pause to quickly write down this formula and the notes. Okay, we want to find the sum of 40 plus 37 plus 34 plus 31 plus 28 plus 25 plus 22. Well, we count up how many there is. There's 1, 2, 3, 4, 5, 6, 7 terms. So that means I'm going to find the sum of 7 terms. So that's equal to 7 over 2, and then 40, which is the first term, plus 22, which is the last term. Okay, that gives me S of 7 equals 7 halves of 62. And that's going to be equal to 217. Okay, well, let's find the sum of the following. The sum of the given integers, 1 to 35. Well, that means that my n is 35, so that's S of 35 equals 35 over 2 times 1 plus 35. Okay, so that's going to be equal to 35 times 18, which is equal to 630. Okay, let's try one more. We're going from 1 to 57, so that's S of 57, F sub 57, so that's equal to 57 over 2, which is 1 plus 57, and that's going to be equal to 57 over 2 times 58, which is going to be equal to 1,653. Next, we want to find the 50th partial sum of the arithmetic sequence -6, -2, 2, 6. First thing we need to look for is the common difference. Well, we do our -2 minus -6, and that's going to be equal to 4. And we can continue on, and we can find that, yes, the common difference is 4. Okay, our first term, a sub 1, is equal to -6. So we plug into our formula. Well, first thing we need to do is find C. C equals -6 minus 4, which is equal to -10. Now we're ready to plug into our formula. A sub n equals 4n minus 10. And that's going to be equal to, we're looking for a sub 50, because we're looking for the 50th partial sum, so a sub 50 is equal to 4 times 50 minus 10, which equals 190. Okay, next we want to determine the seating capacity of an auditorium with 30 rows of seats. If there are 20 seats in the first row, 22 seats in the second row, 24 seats in the third row, and so on. We know they're increasing by 2, so that means that D, the common difference, is 2. We know our first term is a sub 1 is equal to 20, and we know that then that that's going to be a sub n equals 2n plus 20 minus 2, which is 18. So we're looking for a sub 30, which is equal to 2 times 30 plus 18. That gives us 60 plus 18 equals 78. Okay, now we need to keep going because we need to find the total seats. So S of 30 equals 30 over 2 times first term 20 plus 78. Okay, so that's equal to 15 times 98. Oops, not 198, just 98. Okay, and that's going to be equal to 1,470 seats.